Hi student, welcome in our today's session. Today we start to solve our next question, exercise 3.2, that is question number 5. In earlier lecture we see question 1 to question 4. What is question 5? First see the question. Bring out consistency if any in the following data. We have to check the consistency if the given data is consistent or inconsistent. In last lecture we see the properties of regression coefficient. So first property is what? Bxy greater than 1, then byx is less than 1. Then second one we see, that is bxy plus byx divided by 2 of modulus, which is greater than the value of r. And the next one property, that is signs of bxy and byx are always same, and the sign of correlation coefficient r is same as the sign of bxy and the byx. From these properties we have to solve this question number 5. So see what is first question. Here we have given question 5 first. Byx plus bxy. Bxy is equal to 1.30 and r is equal to 0.75. R is 0.75. We have to check if the given data is consistent or inconsistent. So first we take bxy and byx divided by 2, which is equal to 1.30 upon 2. If we divide this, then it is 0. Hence it becomes 1.30, that is 2 6 are 12, and that is 0.65. And all of you know this property. Modulus bxy plus byx upon 2, which is always greater than or equal to. That means this value is always greater than the value of r, correlation coefficient. Since here this value is 0.65 and the value of this r is 0.75, which is 0.65 cents. This value 0.65 and this is value of r is 0.75. Hence this condition is not satisfied here. If the data is consistent, if this condition is satisfied, but here this value 0.65, given value of r is 0.75, which is less than the value of r, hence the given data is consistent. Therefore given data is inconsistent. If it is if this value is greater than the value of this r, then we write here given data is consistent. Now see the next question, that is second question. Byx and bxy is equal to minus 1.50 and r is equal to minus 0.9. Minus 0.9. See here, all of you know that the sign of r, correlation coefficient, is depending upon the sign of regression coefficient. If the sign of r is same as the sign of byx and byx, but here the sign of r is not same as sign of byx and bxy. Therefore given data is inconsistent. Is depending upon the sign of bxy and byx. Next see third question. Byx 1.9 and bxy is minus 0.25. Always remember that the sign of bxy and byx are always same. Either it is positive or it is negative, but same. But here sign of byx is positive and sign of bxy are negative. So signs of bxy and byx are not same. Therefore given data is again inconsistent. Given data is also inconsistent. Next see the question number 4. Byx 2.6 Byx is 2.6 and b1x is 1 upon 2.6. Now see here, we all of you know that b1x greater than 1 and bx1 is less than 1. Then the data is consistent. So see here value of b/x is 2.6 and the value of bx1 1 upon 2.6, that means which is 0 point something. Hence here b/x is greater than 1 and bx5 is less than 1. Therefore right here, therefore and bx1 is 2.6 and which is less than 1. Therefore data is consistent. Therefore the given data is consistent here. Remember that these are the question for you. Whole question is depending upon the properties of regression coefficient, which is very important. Now see, going to next question number 6. What is question 6 here? Two samples from bivariate populations have 15 observations each. The sample means of x and y are 25 and 18. The corresponding sum of squares of deviations from respective means are 136 and 150. The sum of product of deviations from respective mean is 123. Obtain the equation of line of regression of x on y. That means here we have given the all information. So let us consider question number 6. First we have here two observations or two variables x and y and 15 observations. So here n is equal to 15. Now second see the sample mean of x and y are 25 and 18. Sample mean of x, that is x bar 25 and mean of y bar, that is 18. Next, corresponding sum of square of deviation from respective mean. Sum of deviation of squares of deviation from respective means are 136. That is summation xi minus x bar square. Sum of square of deviation from their arithmetic means. First one, that is 136. And the summation of yi minus y bar square is equal to 150. Next, the sum of product of deviations, that means product of these two deviations, xi minus x bar into yi minus y bar, sum of product of their deviations is 123. 123. Obtain line of equation of line of x on y. So we have give all the information. We have to simply find the equation of y on x. So let us solve this question. First, to find line of regression of x on y. That means first we have to find dx1. What is formula for this? That is summation xi minus x bar into yi minus y bar divided variance y. Summation yi minus y bar square. What is product of these deviations? 123 upon yi minus y bar square. 150. Summation of xi, that is 123 here. Hence, see what is 123 or 120? Product is 123, hence the answer is 0.81. 123 upon 150, that is 0.81. Now we have to find line of regression. That is x minus x bar is equal to bx1 into y minus y bar. X minus x bar mean 25. 0.81 into y minus y bar. Y minus y bar is 18. Therefore, x minus 25. 0.81 y minus 0.81 into 18. So if we take product of this 0.81 y minus 0.81 into 18, that is 14.58. Therefore, x is equal to 0.81y minus 14.58. The minus 25 here it become plus 25. Therefore, x is equal to 0.81y minus 24, that is 10.42. This is line of regression of x on y. Now see the next question, that is question number 7. For a certain bivariate data, we have given mean and standard deviations of the two variables x and y. See, question 7. Mean and standard deviations. For mean of x is 25 and 20. And standard deviation 4 and 3. Also here we have given r is equal to 0.5. R is 0.5 and question is asked here, find y when x is equal to 10 and second x when y is equal to 60. So first, if we have to estimate y when x is equal to 10, that means first we have to find the regression equation of y on x. Line of regression of y on x, that is Vy(x) is equal to, first we have to find using this information. So don't write the formula for summation and like. So r into what is Vy(x), that is sigma y upon sigma x. What is value of r given? 0.5 into sigma y 3 divided by 4. So 3.5, that is 1.5 upon 4. We take it in digits, that is if we multiply this by 2 and divide by 2, hence it become 1.5 into 2, that is 3, and here it is 10. Hence we get the value of Vy(x) is 3 by 8. Therefore the line of regression of Vy(x), that is y minus y bar, is equal to Vy(x) into x minus x bar. Y minus y bar 20 is equal to Vy(x) 3 by 8 into x minus x bar 25. Therefore, y minus 20 is equal to 3 by 8x minus 3 into 25, 75 upon 8. Therefore, y is equal to 3 by 8x minus 75 upon 8. The minus 20 will become plus 20. 3 by 8 minus 75 plus 160 upon 8. Here x. 3 upon 8x minus, that is plus 160. So it is 85 upon 8. This is line of regression of y on x, but we have to estimate this y when x is 10. So when x is equal to 10, therefore y is equal to 3 by 8 into 10, 85 upon 8. That means 30 upon 8 plus 85 upon 8, 30 plus 85, that is 158. If we divide, then we will get y is equal to 8 ones are 8. Here remains 3. Now it is 35. 8 fours are 32. Now it is again 3. Now it becomes 30. Now 8 threes are 24. 8 threes are 24. Now it is 60. 8 threes are 34, 60, and 8 sevens are so 14.37. 56. 14.37. Now see the next, that is find line of regression of x on y. Line of regression of x on y, that means dxy is equal to r into sigma x upon sigma y. R 0.5, sigma x 4 and sigma y 3, since 4 upon 3. Look at here, 4 into 5, 20, that is 2.0, hence it is 2 by 3. dxy, so write equation x minus xy is equal to dxy into y minus y bar. X minus x bar 25, dxy 2 upon 3 into y minus y bar, mean of y 20. Therefore x minus 25 is equal to 2 by 3 y minus 2 into 20, 43. Therefore x is equal to 2 by 3 y minus 40 upon 3, the minus 25 here is equal to plus. Therefore 2 by 3 y minus 40, so 25 plus it is 75 upon 3 is equal to 2 by 3 1 minus 40 plus 75, so 5 and 7 minus 4, which is 335 upon 3. X is equal to, but we have to estimate this x when y is equal to 16. X when y is equal to 16. Therefore x is equal to 2 by 3 into 16 minus, here it is, plus 35 upon 3. So 216, 32 upon 3 plus 35 upon 3, 5 plus 2 was 7, 67 upon 3, that is 3, 3 2s are 6, again it is, again 3 2s are 6, now it is 1, 10, 3 3s are 9, again it is, that is 20, 22.33. This is x and this is y. Now see the next question. Question number 8, which is again a same question. Here we have also again give the same values, mean and standard deviation, and the values of x and y. Again, which is the same question as like our earlier question. So you should try to solve this question. Production and demand. Production is x and demand is y. Again we have given its mean and the standard deviation. Mean of production is 85 and the demand is 90. And here deviation is 6. Also here we have given the value of r, that is 0.6. X bar 85, y bar 90, sigma x 5 and the sigma y 6. And here we have to find, estimate the production when the demand is 100. Estimate the production, that means estimate x when the demand is 100. That means we have to find the x when value of y is 100. That means we have to find the line of regression of x on y. Regression of x on y. Estimate the production. What is production? That is called as a x and the demand is said to be 100. So estimate x when y equals to 100. Demand is 100. So first simply we find the dxy. dxy is equal to r into sigma sigma y. What is r? 0.6 into sigma x, 5 upon 6. Again it is 5 upon 6. So 6 5s are 30. That is 3 by 6, which is 1 upon 2. That means which is 0.5. Now next we are going to find that is line of regression of y on x. Line of regression of x on y. That is x minus x bar is equal to bxy into y minus y1. X minus x bar mean 85 is equal to bxy 0.5 into y minus y bar 90. X minus 85. First open the bracket. 0.51 minus this is 0 and 9 5s are 45. Hence it is 40. Therefore x is equal to 0.51 minus 45 and the minus 85 here will become plus 85. 0.51 plus 5 minus 5 0, 8 minus 4 40. So this is line of regression of x1 y, but we have to estimate this production x when the value of y given, that is value of y is 100. So when y is equal to 100, so estimate is therefore x is equal to 0.5 into 100 plus 40. So if we divide this, then it becomes 50 plus 40. Therefore x is equal to 90. Since here the production will be 90 if the demand is 100. So right here production will be production, that is called as an x, will be 90 if demand is 100. We have to solve and what we have to ask here? Regression of line of equation. Also estimate the production. First question, obtain the two line of regression of x. So first we have to find line of both equations here we are going to find. That is line of regression of y on x. That is by(x) is equal to r into sigma y upon sigma x. R is 0.6 into sigma y 6 upon 5. Since here 3.6 divided by 5. Again we estimate the value of y, that is 0.72 by(x). So write the line of regression of y on x. Here we have to find the two regression of line of equations. Therefore line of regression of y on x, that means y minus y bar is equal to by(x) into x minus x bar. Y minus y bar 90, by(x) 0.70 into x minus 85. Open the bracket. 0.72x minus 0.72 into 85, that is 61.2, and if we add the minus 90, 0.72x minus 61.2 minus 90 here it becomes plus 90, that is 0.70. Sign of 90 is positive, hence 0.72 plus it is x here 28.8. Therefore this is a line of regression of y on x, but here we have to find only line of regression of y on x, and here we have to estimate x when the demand is 100. So the next question, question number 9, is again a very easy question. Here we have give already data and we have to find the linear line of linear regression, that is x for y is equal to 10. So you should try to solve these remaining questions. Thank you.